So this is the second assignment on week 9 Thursday. Well, technically it's not exponents anymore, it's radicals, right? All right, so let's take a look at this. Read the first question first.
Formula for kinetic energy of an object is V equals 2 square root 2 over m, where E is the kinetic energy in joules, m is the mass of object in kilograms, and V is the velocity of meters.
Where do you put 50? What is 50?
50 is E.
Good. You put right there. Where do you put 70?
70 is m.
Top and bottom. You see that? So we're going to put V equals square root 2 times 50 times 70, right? Over 70. Notice the square root is only on the numerator, so on the numerator, right?
Yeah.
You can't just cancel the 70 top and bottom because the 70 is in the square root. Do you see that?
Yeah.
Okay. Can't cancel 70. Why? This is not the same. Do you understand?
Yeah.
Okay. Well, let's try to rewrite this part. Let's multiply everything first. So 2 times 50 is 100. 100 times 70. 7. 1, 2, 3, 1, 2, 3 zeros, right? Right?
Mm-hmm.
Do this on the side. What times what gives me 70? 7 times 1,000, right? 1,000 is gonna be 100. That's a perfect square, right? Times 10, correct? So just remember, this is all in square roots, right?
Yeah.
So then you know that this becomes a 10. So it's 10 square root 70. Does that make sense? Okay. Equals. And my, wait a second. I don't know why it's not working. So annoying. Okay. Okay, now it's working. Equals. This right here is gonna be 7 or 10 square root 70 over 70, right?
Yeah.
Now what can you reduce? What does that become right here?
That becomes a 7, and the 10 becomes 1, so then it's equal to 7.
That's your answer. Does that make sense? Do you see that? Right here? Like this part right here?
No, like
this part?
No, the one with the 100 that's like super.
Point to it. I don't know what you're talking about.
I don't know what
Okay.
look like after.
7,000, right?
Yeah.
You know it's 7 times 1,000, correct? This is still a square, correct? Here, you know it's 100 times 10 because 100 is a perfect square, correct?
Yeah.
This you can take out, correct? Square root of 100 is 10, correct? These two stays in. 7 times 10 is 70. You can't do anything with square root of 70. There's no perfect square that gives me 70, right? So you just put it like this. Square root of 7,000 equals this right here. Do you understand? So try that on your own once and see if you can get that too. Okay, number 2, read please.
Where D is distance miles and A is the altitude. How far is the horizon from the hot air balloon at an altitude of 500 feet?
Okay. Where do you put the 500?
in the A.
What is A?
A is the altitude.
Yeah. B equals square root 1.5 times 500, right?
Yeah.
Do the math. Here, you can also do 1.5 times 5, right? 7.5, correct? 7.5, but there's 2 zeros. So you go 1, 2. So this entire thing is 750.
Yeah.
Is that what you have?
Yeah.
Okay, good. Now, when you do 750, you break it down. Immediately, I know that I can do 5 times, I'm pretty sure 25 actually, right? 25 times 3 is 75, correct? That's fine. But I know this is a perfect square, correct? 30 is not. This doesn't give me a 5 square root 30. And with 30, there's nothing else you can break down. 4 doesn't go into it. Because all the perfect squares, 4, 9, 16, 25, right? None of these numbers go into 30, right? So this is going to be 5 square root 30. That's your answer. Does that make sense? Do you see that? Okay. Try it yourself. See if you can do it yourself. You want to use these numbers. These are perfect squares, correct? But if you didn't do that and you did, okay, so this one is square root of 750, correct? You did 5 and 150, right? Well, 15 times 10 is 150, correct? This is 5 times 3, correct? This is 5 times 2, right? In order for you to take something out, you need 2 of the same. 2 of the same number. Do you have any number that's 2 of the same? 1, 2, correct? So that means I could take a 5 out, right? But then what's left? 3, 5, 2. Do you see how none of those are 2 of the same? So you multiply them back together. 3 times 5 is 15. 15 times 2 is 30. Do you see how it's exactly the same answer? So it doesn't really matter, how you break it down, but
Those are perfect squares.
5 and 5 gives me square root of 25, right? Which is 5. You forget that there is actually a square root here. I just didn't write it, but there's a square root on that one, right? Okay. Number 3.
The equation that models the motion of the pendulum is T equals 2 pi square root L over G. Variable T is time in seconds, I is the length of the pendulum in centimeters, and G is the acceleration due to the gravity, 980 centimeters per second squared.
All right. Keep on.
Sorry.
You're fine.
Determine the time it takes a 75-meter pendulum to move one.
What do you put 180?
I put 980 on the I.
What? No, I think G. Isn't G? G is acceleration due to gravity, isn't it? Which is 980. Shouldn't that be 980 is G? Right?
I don't.
I think so. G is acceleration due to gravity, which is 980 centimeters, right? L is the length of the pendulum in centimeters. So L is a length. Well, it says it takes 75 centimeter pendulum. So isn't that the length right here is the 75? Do you see that now?
Yeah.
Okay. Because the question says determine the time. So it says determine the time, it means find T, correct?
Yeah.
Well, T is right there. So it wouldn't make any sense to put 75 in T because that's what you're trying to find. Does that make sense? So you gotta read it and kind of analyze it like that. Okay, and you're probably tired, so So t equals 2 pi square root. Notice the square root is on the top and the bottom. Do you see that?
Mhm.
So I'm going to put 75 on top over 980, okay? Now our focus is, before we do anything on the outside, let's just go ahead and rewrite the part that's highlighted in yellow. You see that? So the part that's in yellow, it's square root of 75 over square root of 980, okay? Start out with 75. 75, what's the perfect square that go into 75? The perfect square is right here. 4, 9, 16, 25. Which one do you think goes in there? 5 is not a perfect square. Perfect squares are 4, 9, 16, 25.
25.
Yeah. 25 times 3 is 75, isn't it? Square root of 25 isn't give me a 5, but that 3 stays inside. Do you see that? Okay, so that's the top. That's the numerator. Denominator. Which one of these here, 4, 9, 16, and 25, is a factor of 980? You think?
Um, 16.
16. Okay, so 16 times 12 gives me 980.
Sorry.
That's okay. I don't think 16 goes in there perfectly. Can't use 16. Gives you a decimal. So what's another number besides 16? Maybe start with a smaller number.
No.
How about 4? I don't think 9 will go into it. 9 goes in there 9 once. 9 times nothing gives me 80. 9 times 9 is 81. So 9 doesn't work.
Okay.
But maybe 4. So start small. That'll work.
Maybe 45.
Good. Which perfect square is divisible into 245?
Just try 4 again.
I don't think 4 will work. Think about it. 4 doesn't go anything into 5. 4 times anything doesn't give you a 5 at the end. Okay, remember when we went over the divisibility rules with your teacher last year? If it ends with a 5, it's probably divisible by 5. So let's divide it by 5.
I thought we couldn't do that.
Do what?
I thought we couldn't divide by 5.
Okay, you want to try to find the perfect square, but if you can't find a perfect square, you find another number that you can go into it. Because ultimately, it's going to break everything down, right? You want to use the perfect square because you know there's a perfect square in here somewhere, correct? It doesn't matter if you use the perfect square or not. Just break this down to the prime factorization. You still do the same thing. So none of these other works, but you can still break that down, correct? So try 5.
Five and 49.
Good. So which one are perfect squares so far? So what times what gives you 200 or to give you 980? What are the 3 numbers that multiply give you 980? There's no 25.
3, 5, 1.
There's no 3. We started at the 4. 4 times 245 is 980, correct? Then we broke this down, correct? 5 times 49 is 249. So the only three numbers you should have are the three numbers I'm highlighting right there in yellow. Do you see that? Do you see that? Nine. Yeah. So 4 times 5 times 49 equals or 980, right? Okay, so these are the factors. But then from looking at this, you also know that 4 and 49 are perfect squares. You get 2 times 7, correct? That 5 stays in there. So if I reduce it, it's going to be 14 square root 5. Do you see that? So this is a very long process. Okay, so 75, we got 5 square root 3, correct? 980, we got 14 square root 5, right? Fortunately, we cannot cancel anything. Do you see that? But don't forget this part because there's a 1 right there, right? 2 times 5 is a 10. Pi square root 3. 1 times 14 is a 4. Square root 5. Do you see that? I think at this point you can keep it here, but there's a rule here. No square root in denominator, okay? So is there a square root in a denominator? Yes, there is. It's a square root of 5. Do you see that right there?
Yeah.
So how do you get rid of it? Multiply square root of 5 top and bottom. Because isn't the square root of 5 top and bottom just going to give you 1? Right? You can always multiply anything by 1, right? So if you multiply the top by square root of 5, multiply the bottom by square root of 5. Do you see that? And the reason why I want to do that is because, look, square root of 5 times square root of 5. What's 5 times 5? What's the square root of 25? See how we got rid of the square root of 5 right there? So when we do that, it's going to be 14 times 5. Do you see that? So 14 times 5 is going to be a 70. Do you see that? No square root. Okay, 10 pi stays the same. Square root of 3 times square root of 5 is a square root of 15. That's your answer. It's a little bit complicated, okay? And we'll probably practice that again. So just copy it down for now. Does that make sense? Yeah, just copy it down, and then we'll move on. We'll practice a little bit more over. Number 4, read.
The formula t equals square root of 2b over g gives the time t in seconds that takes an object to at rest to follow distance of d meters. The acceleration due to gravity is g meters per second squared. On the moon, the acceleration due to gravity is 1.6 meters per second squared. If an object is dropped from a height of 3.2 meters on the moon, how long would it take to reach the surface?
Okay, so you have to decipher this. Okay, so first number that you give you is 1.6 meters. What is that? Look, you have a T, you have a D, and you have a G. So which one's that going to be? So 1.6 is a D or is a G or is a T?
1.6 is g.
Yeah, because it says due to gravity, right? But you're like, well, what is due to gravity? It doesn't say it's G. But if you look at the sentence that's above that, do you see due to gravity is G meters? Do you see that? So that's going to be 1.6, right? So you got to make that decision. Next letter or number given to you is 3.2 meters. What is that going to be? What letter does that represent?
D.
Yeah, height. Where does it say D is the height?
D meters when acceleration.
It says fall at a distance of D meters. Do you see that? So it's not always behind it, sometimes before that. Okay, so let's rewrite this. T equals square root, and notice the square root is the numerator and denominator, right? 2 times D, or hold on, D is going to be right here, right? So 2 times 3.2, right?
Mhm.
over G. G is 1.6, right?
Mhm.
Okay, well, first thing I want to do is I want to multiply the numerator, okay? So 2 times 3.2 is
200. 6.4.
6.4. Okay, do you see on the bottom? Okay, so here, look over here, Grayson. There's a rule in math. If it's square root of A over B, you can always split it to the square root of A over the square root of B. Do you see that? Do you see how here I went ahead and split it?
Yeah.
Right? I can't break this down because it's not a whole number, it's a decimal, right? But there is a rule in math that says what? No square root in denominator, right? You can't have a square root in denominator. So how do you get rid of the square root in denominator? Multiply it like this. Does that make sense?
Mhm.
So we're gonna multiply square root of 1.6, square root of 1.6. Because technically this is just 1. Do you see how this entire thing is just 1? You can multiply anything by 1, okay?
Mhm.
All right. When you have, okay, so look at this. When you have, for example, square root of 2 times square root of 2, isn't that 2?
Mhm.
Square root of 1.6 times square root of 1.6 is going to be 1.6. You see that? That's done. Now here, you got to multiply this number by this number. So what's 6.4 times 1.6?